Right then, good afternoon, everybody. I'm Tim Perry, Pim Terry on Twitter, and my slides have immediately disappeared. Oh, this is great. Oh dear. All right. So I'm Tim Perry. I work for a company called Softwire, and I'm going to be talking about build processes. Specifically, I want to look at some build smells, some ways we can spot issues in our build processes in the tools we're using, and ways we can try and recover from that. So we're going to go through 3 specific examples of these and look at how these problems will appear in your teams and how we can do better. So for some context first, I work for Softwire. We're a bespoke software development company. So we make everything for everybody else. Startups you've never heard of, all sorts of other little companies, big places like the BBC and Cisco, everybody. And a lot of this involves working very, very closely with other teams in other companies. So we get to see how a lot of people do things wrong and right in some cases. And we get to get involved in helping them improve that and helping build up from there. So a lot of this talk is building on stuff we've seen in practice. This is all going to be fairly concrete rather than theoretical. I'm looking here at specific issues we see companies actually fighting with day to day and ways we can work on that and things we find work well in practice. When I talk about builds, what I specifically mean here is the tools and processes that take your code that you've finished and you're happy with on your machine and do everything else until you get it into a customer's hands, right up until the bit where you've got something that actually does something useful for somebody. Why do we care about this stuff? This is the pipeline that does anything useful for your system. If you've written a bunch of code and you haven't given it to your customers, it's not useful to anybody. Nobody is interested in that. And this is the tool you use to do that. This is the tool that does everything you care about. This is the only thing, really, that matters. So this is quite important, and we want to try and build this up. We want to turn this into something that is genuinely going to be useful. And we want to use this to be able to develop software faster and better. I want to be clear that I'm not proposing you try and design the perfect structure to do this up front. You don't really want to sit down and design a perfect plan for this because you're going to do so wrong. That's going to be very painful. It's going to be an awkward process. And instead, this is very much a kind of gardening process. You focus on what actually hurts, concrete pains you see in your team, and ways that you can actually improve that, things you can change that can give you definitive benefits. Rewriting your tools in Haskell, adding all these extra fancy, shiny things is probably not a good idea. We're trying to make changes here that we can see fixing individual actual problems that you're fighting day to day. So let's dive into the first smell, painful merging. So we see quite a lot of companies where you end up with teams where people are racing to push things because they don't want to have to deal with the repercussions of merging with the rest of their team, because they don't want to have to deal with the conflicts, deal with the hassle around that. Not only does that result in you pushing code at times differently to really when you want to be doing it, also potentially you end up burning lots of time actually fighting conflicts. And generally it puts a barrier up between you and sharing code with the rest of the team. You see this on a lot of projects on a small scale where you're losing bits of time here and there, but we see lots of companies where this becomes normalized, where you accept that every week somebody's going to spend a day resolving merge conflicts, and you're burning a huge amount of time there. And you see this get even worse in really large companies. Not only do you burn time doing this, you also make yourself worse at development. You can't do big, wide-scale refactorings if you're expecting to see conflicts. Even if they don't actually happen, that fear, that worry, is pressuring you against making wide, cross-cutting changes in your codebase, because such refactorings will have huge conflicts. So as soon as you get into this position where you as a team are fighting against merges, even where you're just worried about these conflicts, you really start having your tools making you worse at development. Critically, a huge number of these conflicts are actually completely avoidable. And you can see this best if you break it out into the kind of conflicts we see day to day. So you get basic syntactic conflicts. Say you have added a method to a class, somebody else on your team has added another method to that same class, and you happen to have done it in the same place, but they're totally independent methods. At this point, you've got a syntactic conflict. Your version control is going to complain and point out that you need to resolve this somehow. But actually, these are totally independent changes. It doesn't really matter. And it's a very easy problem to resolve when you have only one of these. You put the methods in either way round. It doesn't matter. But these are very, very simple. They're very easy to resolve when you've got one, but become much more difficult if you've got hundreds. And if you make these changes sequentially, they totally disappear. If you add a method, and then I come and add a method, I'm just going to add it. I'm never going to see a conflict. That problem totally disappears completely transparently with no thought or effort at all. Even if we go into a sort of basic level of semantic conflicts, so let's say you've changed a method so that instead of returning meters, it returns centimeters, and somebody else on your team has written some new code that calls this method. These are syntactically separate. Version control isn't going to realize you've got a conflict here, which is quite dangerous. But you're probably not going to get the behavior you expected. You're going to get weird interrelationships here that break your code. These, again, in these simple cases, are quite easy to solve. If the method was already written in centimeters, you would have written it correctly if you were making these sequentially. And even once you realize that's a problem, it's a very easy change to make. So once you know you've got this issue, it becomes much simpler to manage. Making these changes sequentially instead and trying to find out about these issues earlier makes that much simpler for a huge number of conflicts. You do still get larger, more fundamental conflicts where you want to refactor a bunch of code that is going to require you completely remove a method that you can't support in the API anymore. And I want to write a bunch of new code that uses this method. Whatever happens, however we do this, there's going to be some pain there. But again, finding out about that earlier really reduces that pain. Even though doing this sequentially will have a conflict, if we find out earlier, that becomes an easier conflict to resolve. If I know about this immediately, we can have a discussion about the fact that we're trying to do two mutually exclusive things. But that is a fairly rare case. Having two people on one team trying to make two changes that are mutually exclusive that you cannot do is something that actually doesn't happen very often. And most conflicts simply disappear if you make changes in sequence. The thing fundamentally that causes these is isolation. Every time you keep code on a branch, keep it locally, and you don't share it with the rest of your team, you're isolating that change from the rest of your team. You're keeping secret changes to the code, and other people in your team can't make changes to their code with respect to yours. They can't make changes while keeping your changes in mind. They can't do a refactoring and also refactor the code that you're about to include. If instead you share the code, they can do this. They've got more information. So this isolation does come with a cost. It causes these kind of problems we see here. And this gets exponentially worse. The longer you keep code isolated from the rest of the team, the more painful it becomes when you merge, quite significantly. Not only do you have more code to merge in, everybody else on the team has more code that you're going to be merging with. And so certainly we've seen people where teams keep code on branches for a month as standard, as they build huge, vast features and they merge them in. And this is, as you can imagine, fairly catastrophic. It takes a lot of time merging and resolving these conflicts. And once you've actually done so, you end up with all sorts of interesting, subtle bugs. So we want to try and avoid this isolation. This isolation comes with a quite concrete cost. And the really core route out of this is sharing your code earlier. Anything you can do that puts the changes you're making into the other developers' hands on your team reduces this isolation. And what we've tried to do on teams that are struggling with this is pushing to a point where you share your code every time it works. So every time the tests pass and it doesn't functionally break something in the application, you share it with the rest of the team. And that is typically much more frequently than you normally do. So a lot of teams build stories, and they try and build small stories, but you try and build out an entire piece of functionality and then share that with the rest of the team. But there's a lot of ways you can break up that functionality, share the changes you're making earlier, reduce the isolation, and for free, completely get rid of this problem. Provide the rest of your team with more information, less isolation, and work more closely together. It is slightly easier said than done, of course, so we can go through some examples. If you've got tests, for example, let's say you've found a bunch of code you want to refactor. You've found it's not very well tested, so you're going to write a passing test for it first, and then you're going to refactor it. Once you've written that passing test, once it's passing, the code is immediately back in a state where it's shareable. The tests pass, you haven't broken any functionality because it's a test, and immediately you can commit that and share that with the rest of the team. And as soon as you do, you make it impossible for you to get conflicts on that test. Anybody who wants to refactor all the test suite is also going to refactor your test. Anybody who changes some functionality that breaks this is immediately going to find out, rather than a week later when you try and merge this branch in and it's a catastrophe. So as soon as you've got passing tests, you can share this stuff. And even for failing tests, you can get quite a lot of this benefit. You can ignore failing tests, and as long as you have the rigor within your team to make sure you actually catch up with these later, you can ignore failing tests, share them, and again, immediately refactoring and things, issues will come up sooner. People will resolve conflicts much quicker if you can share this stuff. Even within your models, you can do a lot of this. So if you add a new field to a model, most of the time that's not going to break anything. You can immediately share it with the rest of the team without causing any problems. Even if you start adding new methods to models, to components within your system, these methods typically don't break anything for anybody. You can add these individual working chunks of functionality as you develop, and you can immediately share those. We really try and push for sharing absolutely everything when this starts to become a problem. You can quite quickly get to a stage where you are making small changes on the order of an hour or so and then sharing your code with everybody else. And you really quickly get into a nice tight loop here. This is not only quite good for solving this problem, it's also just a very good way of working. If you start developing a feature and you end up in these huge refactorings and these bigger and bigger changes, they're going to conflict. But also, you really lose sight of the changes you're making. It becomes difficult to understand what you're doing, difficult to really think about where you're going, and difficult for people to look back at what you've done. And instead, in addition to the conflict benefits, just trying to focus on small incremental changes in many short steps that you share with the rest of the team has a huge amount of benefit for this kind of stuff. Feature flags can be helpful when this gets more difficult. So this is essentially the process of branching within the code rather than within version control. So let's say, for example, I want to rewrite the user page in my application. I've got a big, fancy user page, and I've got a great new design for it. This is going to be quite difficult to share with the rest of the team because it's going to be a big change. That's going to take me a while to do all this stuff. So instead of branching this off and isolating myself until it's all done, within the code base, you put in an if statement, essentially, checking for some config. Is the new page enabled, or is new user page enabled, or the old user page? If the new user page is enabled, you show the new half-built one. If the old page is enabled, you keep showing the old page, so you keep both functionalities in there. You set this config to be disabled for everybody else. So you can share the code immediately. Everybody else still sees the old functionality, but the code is already shared. So everybody else running locally still has the old user page coming through, but locally you, as a developer of the new user page, can turn this config on, develop that, and see that, and you can share the code immediately. This requires a degree of rigor. If you get distracted and just start leaving these and not cleaning up after yourself, you can end up with a code base riddled with many, many if statements for the many different features you've ever thought about adding every time you added one. And that becomes very painful. So you have to ensure you're cleaning up after yourself here. But if you're doing that, there is quite a lot of concrete benefit that comes out of these. People like Facebook and GitHub particularly, you take these even further and start using them to manage deployment to users. You can turn on feature flags for just your alpha users to roll out features progressively to individual people in your system. And if you really invest in these, they turn into a feature in and of themselves. There's quite a lot of value around deployment once you start digging into this. I don't really want to claim at all that branching is always a bad idea. It's a very, very powerful tool. Version control is really, really good at branching nowadays, and that is a really useful thing. The problem is when people start treating branching as the tool to use for everything, as using it by default, because the isolation that comes with this has a cost. You are paying a penalty for doing that. And if you're branching without a specific good reason, you end up paying penalties for no benefits. There are lots of good reasons. If you're tracking branches for hotfixes for your release versions, for example, that makes perfect sense. If you've got some very experimental code that you're probably not going to be merging in, keeping it on a branch makes more sense. If you're running open source communities where you can't have people merging into master willy-nilly, you can't trust the people who might be immediately contributing automatically, then you need to manage branches and so on here. But doing them by default is where we get the problem. You want to actually have a reason before you start adding this isolation, and try and keep it as short as possible. Even if you're doing pull requests and so on for things, try and have many short pull requests rather than one huge week-long, month-long bunch of work. So we start in a situation where merges are scary, where people are racing to fight these conflicts, and instead we move towards small, frequent, much easier merges, sharing code as quickly as we can. So we've got a bunch of changes that we've made. That's great. We have to share it with the rest of the team, and you can get into a situation where this is very scary, where you've got a bunch of code, and when you push it, you have no idea what's going to happen. And what's probably going to happen is the build is going to break for no good reason and send you a whole bunch of frustrating emails. This is pretty bad. This is clearly a smell that something has gone wrong in your team if you as developers are having to worry about this kind of stuff. If you have to think about this, not only do you lose time actually going and fixing the build from here, you also lose focus. You can't focus just on the thing you're developing right now. Instead, you pick up a new story, you start developing that, and then you have to look back and, oh, this is broken, what was I doing? And you lose your flow, and you can't just concentrate on getting stuff done. You've got all these distractions. You need to have that confidence that stuff's going to work. If you ever get into a situation where you're saying something like this, for example, something has gone very wrong. You've got a bunch of code on your machine, and you don't know what's going to happen when you push it onto the remote server. And what's probably going to happen is it's going to break, and you're going to get distracted, and you lose a bunch of time. Development becomes less fun. You lose that flow that lets you get stuff done very well and very quickly. Similarly, this kind of thing. You've pushed it to the remote server, and you still don't know what it's going to do on the remote server. As soon as this kind of stuff is happening, you've got smells in your build process that suggests something is going wrong, and you need to resolve these. This costs you a lot of time, a lot of focus, and makes you worse at development. What all this really comes down to is confidence. If you imagine the times when you were doing development really, really well, it's typically when you're building something, you make a bunch of changes. Does it work? Oh, no, this doesn't work yet. Yep, ooh, nah, cool, done. Next thing. And you can focus on what you're doing one thing at a time, and you can quickly work out what works so that you can iterate to a state when stuff is working well. Getting that confidence allows you to do really fast, really good, really effective development. And as soon as you start breaking this stuff, you lose that completely. So how do we get that? There's 4 main bits to this, I think. Accuracy, so you want your build to actually reliably tell you whether the code works. You don't want these tests randomly failing. Thoroughness, you want your tests to actually really represent the state of your code. So if the tests pass, the code is actually any good. And then you need to be able to get quick feedback from this, and you need to be simple to run this whole process. Accuracy, so the really core things to getting accurate tests are trying to eliminate the outside influences. So particularly in unit tests, cutting down to absolutely no dependencies makes your tests much more reliable. I'm talking about external dependencies on services, obviously, but also time and time zones as much as you can, operating system specifics. We see lots of systems, again, where people have local Windows machines and Linux build servers and this kind of thing, and path separators are different, and the tests don't work properly on my machine, so I never run them on my machine. And you destroy all the confidence and so on in this. And if you can instead remove those dependencies and get everybody working in identical environments, so Vagrant and Docker and things really help with this kind of stuff, then you can move into a place where you can get this accuracy, this reproducible process of testing. And finally, having a zero tolerance. As soon as your tests start becoming unstable, you really have to jump on it, because even if you just have one that flickers on and off, people stop really caring about the build anymore. People stop dealing with it as that gets worse, and that will quickly get worse. But also people stop even noticing when the build actually fails. When you get real failures, people just run it again a couple of times, and then maybe they'll start looking at it. And that wastes so much time, and means by the time you actually fix it, it's not 5 minutes after you made the change, it's an hour. And you no longer really understand what you're doing, and everybody else is annoyed by these emails they're getting, why is the build broken? And it gets much, much worse. If you have to, just ignore the tests. If you can't fix it, there's no value to a test that randomly fails, because nobody looks at or trusts the result. Lots of other tools have middle ground, nicer ways of doing this. So Jenkins particularly has a plugin for quarantining tests. So you can say, this test is unstable, so don't use it to decide whether the overall build has passed or failed. So you can now trust failure. But do still run the test, so you still get that result. And that hopefully gives you enough pressure that you actually eventually go back and fix it. But if you're never going to fix it, get rid of it. Having an unstable build is really as bad as not having tests here. Thoroughness. OK, so we've got a bunch of tests. Do they mean anything? Does our code actually work? People really like coverage for this. There's definitely ways to do that badly. Line coverage is a quite imperfect metric. By and large, most of the teams where, over the long term, you set some arbitrary goal that you're going to stick at, get problems from this and lose confidence in their build. If you've got 80% line coverage, you will find the project, if you've got an 80% line coverage target, you will find the project has 80.5% line coverage. And sometimes people make changes that drop it below that. The build will randomly fail. They will get frustrated. Everybody will get frustrated. Sometimes you can make a change that makes the code base better, that marginally drops line coverage. And again, you destroy trust. The useful bit we find in coverage is the trends. If your coverage is going up, you're probably in a pretty good place. That is very useful information. That indicates something is probably going well. If your coverage is going down, you probably have a problem. Similarly, if some areas of your code base are better covered than others, this gives you lots of information about how well your testing's working, what kind of stuff you've thought about, and shows you what you should be focusing on. So this is useful information, and making this visible is quite important, but fixating on arbitrary goals, we find, often causes more trouble than it's worth. The other part of this is really trying to find the right amount of testing to do. We see people at both ends of this. It's quite easy to get into a position where you write unit tests for every getter and setter, and you spend a lot of time writing tests. You have a lot of tests to maintain, and those tests aren't adding any value. And similarly, you get a lot of people at the other end where something is hard to test, so they just don't test it. Both of these are bad. Finding that line requires some practice, but is doable. And by and large, I'd focus on this kind of thing. If you're writing tests and there is no way they are ever going to fail, there's no reasonable change you'd make that would ever break that test, it's probably not a useful test. And instead, testing a slightly larger chunk of the code base that includes that and being slightly less precise lets you cover more of your code base more effectively with less maintenance cost, less waste and hassle and overhead. And similarly, if you've got some risk, if you can see something that might break and you don't have a test for it, maybe because it's difficult, you're in a really bad problem, really bad position. If you can't test something as a unit test, test it really thoroughly as an integration test, but ensure it gets tested somewhere. If you have to push it up, so be it, but make sure everything that might actually break gets tested somewhere. So, speed. So we were talking about good development, that feeling of writing stuff quickly and getting feedback there. That works really well if you write some code and then you see it working. And this is one of the things that JavaScript as a community particularly is very good at, that quick feedback loop. REPLs and so on really help with this. If it takes an hour to tell whether it works, you develop much worse. You write a bunch of code, and then you find out an hour later it didn't work, and then you have to debug an hour's worth of code. And that quicker feedback loop powers good development. So anything we can do to make this quicker adds a lot of value. I'd particularly try and focus on the watchable unit tests bit here. So getting unit tests down to a level where I can write a change, run the unit tests, and I'm not going to get bored looking at them, where I can make a change and go, yep, this works, cool, great, oh, that works, excellent, done. That kind of 10-second kind of mark is much more useful than tests that I'm going to get bored and go off and do something else. Because as soon as you've got that, people stop running the tests. It becomes a hassle. It becomes painful. So people don't do it. And finally, smoke tests. It's very difficult to get system and integration tests, larger, more complicated tests, down to that level where people actually watch them, which means it's very difficult to get them to a level where people actually run them. If you've got a 4-hour system test suite, people are probably not running that every time they commit any code. So instead, trying to pick some representative examples from this as smoke tests adds quite a lot of benefit. So pretty much any testing framework under the sun will have some kind of tagging or categorization system. And you can pick 5 or 10 tests, maybe a test for each page of your application, whatever, that immediately run much more quickly and immediately give you a good idea of whether you've totally broken everything or whether is kind of okay. Like, you can quickly get to a point where people can make a change and then get a actually really high level of confidence they haven't catastrophically broken something. What you really want to avoid here is that situation where I push something up to CI and 4 hours later it tells me that every single test failed, which would have been really, really useful information 1 minute into that test run, and it's extremely annoying information 4 hours later. And if you can get that faster feedback loop, you can get a lot more benefit. So these smoke tests here, both for running locally for this, but also you can have them as a pre-build step in CI, run the smoke tests, and then run the extra bits of the tests and get that quicker feedback loop everywhere you can. But this is a particularly easy bit to just drop in. And finally for this, simple builds, if you want people to actually run them, you have to make them easy. This is very much kind of a UX problem, really, in a lot of ways. You want to guide your users, which for your build is you and the rest of your team, down that path where they want to run the tests, where it's easy and they just do it. Getting it down to one click is really, really key to this. As soon as I have to press a whole bunch of buttons to run all the different suites of tests, I'm not going to. I'm going to forget one. It's going to be difficult. There's no way that one would fail, and then it does. This kind of thing. And by and large, it becomes really easy in most cases to actually stick a script together that just runs all of them for you. And there is a disproportionate benefit to that. People are very lazy, and if you can give them a single button to press that does the sensible thing they should be doing, life gets much easier. And similarly, zero setup. If people have to do a bunch of setup, they'll do it wrong. Boring, mundane setup tasks are a hassle. So trying to remove as much of that as possible will make people better at this, and also gives you extra accuracy. If you have to do manual setup on your local machine to be able to run tests, you'll do it in one way, somebody else will do it in a slightly different way, and the test will pass for one of you and not the other, and then nobody cares about testing anymore, and everybody hates everything. And trying to instead be in this system where they automatically set themselves up. If you've got complicated dependencies, manage them in Docker, this kind of thing. Have some environment that manages itself, that sets up the required dependencies for this. And make this all easily debuggable. Once you've got a bunch of tests, they're going to break at some point. I'm going to be very frustrated. I'm less good at fixing them if I can't individually run tests, for example. If I can't get screenshots automatically from failing Selenium tests, this kind of thing. There's lots of ways you can add that extra debug information. And again, you get disproportionate benefit for putting that together. Cool. So you start in a situation where pushing is scary, where you don't know what's going to happen, where you rerun the build and you still don't know what's going to happen. And instead, you want to try and pull yourself out of that and move into the situation where you've got these accurate, thorough tests that you can run quickly, that give you that quick, confident feedback loop, so you can actually get something done. Finally then, releases. As soon as you get into a situation where you don't release anything, you're in a situation where you're not doing anything useful. The point where you see people having launch parties, for example. We successfully put out a release this year. Great. But what have you been doing for the rest of the year? Like the releasing is the point where you do something useful. And the more you can do this, the more value you're adding. And the less you do this, the more value you're wasting, and the more painful your releases will become. This feeds into itself. Releases are really where the magic happens. All your customers care about is the released code you give them. A bunch of code sat on your machine. It's not interesting to them. It's not useful to them. Whatever you're trying to do with your business, make money, grow something, make people happy, whatever, none of that happens until you actually release code. Critically, the sooner you release code, the more value you add. Not just do you make people happier or get more people or make more money earlier, you also have a lot more information. Once you've released something and your customers have used it, you've got a really good idea whether it works. A drastically better idea than you had the day before. And you've also got a much better idea of what you should do next. Once you've given something to your users, you can get much more useful feedback about where the product should be going next. If you write a whole complicated system and then it turns out that people don't like any of it, that would have been really useful information after you wrote the first bit and launched it. And the sooner you release it, the sooner you get that information, the more value you get, in addition to the extra value of actually releasing something to people. So any situation where we can start pushing stuff earlier gives us more benefit. And any situation where that is difficult, where that is problematic, and where people are avoiding that for technical reasons, is a build smell. So some examples. Facebook, release the whole of Facebook twice a day. Who here releases their project at least twice a day? One hand. Nice. Sometimes more, okay. Good, yeah. Nonetheless, almost everybody is not releasing their project twice a day. I feel pretty confident in saying that the deployment process of Facebook is more complicated than anybody else's deployment process here, and potentially more risky. If Facebook goes down, it is international news, which is probably not the case for your products. No offense. They're getting a lot of value out of this. They're doing something very hard. They're doing something quite difficult in a big and high-profile manner, and they're doing it twice a day. If we look at GitHub, you're doing hundreds of times a week, and they've actually got some really interesting blog posts looking at the specific benefits they get from this frequency of releasing. If you look at like Netflix and people, you get down to hundreds of times a day when you are just continually releasing stuff all the time. These are the industry leaders doing this kind of thing, really. So why aren't we? There's clearly benefit to this. These people are spending a lot of money, taking a degree of risk, putting a lot of effort into this. So why are 99% of you not? I think, certainly from what we see, it's typically quite risky to do so. Like, releasing something that doesn't work is very embarrassing. And it's potentially quite hard. It takes time and it takes effort. So let's make it easier. Try and get into a place where you've got consistent environments. If your staging environment is exactly the same as production, I'm talking software, operating systems, hardware, but also things like data, particularly, which often gets neglected. If you've got exactly the same stuff running in both, and it really works in staging, then you can have really good confidence it's going to work in production. And we find actually trying to get users on staging, so if you ask users to be alpha testers, for example, and use staging with the knowledge that it's going to be broken, you'll definitely have some users that will be quite excited by that idea, and you can get really good confidence that stuff is going to work if you have actual users actually using the thing and it really works. And all of a sudden, releases feel much less scary. Automate everything. People are very bad at boring, repetitive tasks. If you don't automate it, it is scary. Stuff feels risky. It feels dangerous because there's these 100 steps, and if you do any of them wrong, you take down Facebook or whatever, some huge disaster. If instead you've got an automated process set up that does this and has done this 100 times before, I'm going to be pretty confident that the 101st time it's going to work. I have a good amount of faith in that, and it becomes much easier to have that faith when you've got automated deployments. And you can also start then automatically testing these deployments and so on. And finally, measuring everything. One of the really obvious things about all three of these examples here is that they measure everything. They put out great articles about the stuff they measure. They talk a lot about the things they measure. They've built a lot of open source tools to make you measure things better. And as soon as you've got these metrics, you take away a lot of the fear. If you've got a graph showing how much you've sold today, and you do a release, and it keeps ticking up, everything is probably OK. You're still making a bunch of money. Everything is not totally broken. Similarly, if it suddenly plummets down, you very quickly know you have a problem, and you can then deal with that. And immediately, you can get rid of quite a lot of the risk that drastic problems are going to go out and lose you a bunch of money if you can get this measurement, if you can make this stuff visible. I'm just focusing on key kind of business metrics here to make that work. And then, once we've reduced the risk, making it easy. Again, automation is really the name of the game here. People are very lazy. If releasing stuff takes more than 5 minutes, people will release stuff when they have time, and they will never have time. If it takes nearly no time, if I don't have to do anything myself at all, I'll release everything as soon as I've got something I can give to customers. And that is when you want to be releasing things, as frequently as you have something useful to add. Trying to get this down to a single click will really help with that as well. Again, people are very lazy. It's typically much easier than you would expect once you've got most stuff automated to go that last little step to get it down to a single click or less to do so. And there is a disproportionate benefit to that. As soon as you've got that, people will release all the time. And that not only gets stuff out to your users and gets you quicker feedback from your users, it also makes it easier to make your releases better. If people are releasing all the time, you see the painful broken bits of releasing much more frequently. And as you fix them, you get more feedback on your own release process. The easier you can make this, the more benefits you get. And most manual release processes we see are really just go to this machine, run this script, go to this machine, run this script, copy this to here, which is the kind of stuff you can automate really easily. You're software developers, you're very good at this kind of stuff, and there's a disproportionate amount of effort in here. And finally, get everybody deploying. GitHub are a really good example for this. If you join GitHub on your first day, you deploy all of GitHub. That's potentially quite scary. I think you only actually make a tiny change. You add yourself to the team page, this kind of thing. But doing this ensures that everybody knows how to release. Everybody has done a release. It is the very first thing you do. Everybody feels like it's easy. Everybody feels like it's low risk. And it becomes part of the culture. You build a process where everybody is involved and invested in releasing really, really well. If you have just one person doing releases, then if they get ill, obviously you can't release anything, which is terrible. But also, they're the only one who really cares about releasing. They're the only one invested in making this better. And it's the only point where you do anything useful. You want the whole team invested in giving stuff to your customers, because that is the only thing the team is doing that is actually really important. If you have only one person doing this, you really lose that. Building a culture where everybody releases and where it's completely normal for somebody to say, yeah, this works, ship it. But quite worried about doing the next one. So it will get much bigger and it will get much scarier and it will break much worse and so on. And this really builds and builds and builds and puts you in a position where releasing is very, very hard and very scary. And you have to break out of this loop or it just gets worse. If instead you start chasing towards frequency, you start trying to release more and more frequently, then you end up doing smaller releases. You get better at releasing, and it becomes easier and easier to do so. Push for, yes, one click and getting people actually clicking it. Push for automated releases, even if it's not to production. Automated release to a development environment that you use for testing, just to get that automation to ensure that that really works. Build up these processes, and it will make you better at releasing, and releasing will get easier. So, you're in a situation where releasing is scary, where releasing is hard, so you never do it, and you have a big party the one time it ever worked. And instead, you move to this situation where it's easy, where you do it frequently, and you reduce the risk by getting better and better at it, by doing it more and more frequently, and you build this up. And eventually, you can just release all the time, at least twice a day. So, to wrap up, it's important to note that a lot of these are cumulative. So merging, for example, the more merging you do, the easier your merges get, the better you get at it as a team, the more you get practiced at this kind of thing. Releasing particularly, as we've been talking about, the more frequently you do it, the better your release processes become. And it's really easy to undervalue a lot of this stuff by just looking at the time you will save by the single change you're going to make, rather than the time you will then also save by people being more invested in these release processes, by you having quicker feedback about how this works, by you being better at improving. And this stuff builds on itself more and more and more. And investing in this gives you disproportionate benefits really quite quickly. And I should also note again that this is gardening, not architecture. I would really, when you're trying to follow these kind of things, focus on specific pain that you're seeing in your teams. Have a lot of retros, talk about this a lot, get people invested, discuss what actual problems you're hitting up against, and find concrete solutions that are going to improve things. And then look at how they actually work. Measure things, put stuff on graphs, get an idea of concrete evidence for whether stuff is working, and try and iterate and build on that. Prune and weed and let stuff grow as you find out more about your system and what works and what doesn't. That's everything I've got for you. I am Tim Perry, Pim Terry on Twitter, and I'll stick the slides out there later. And that's a lot. Thank you very much. I think we might have one or two next questions.
Yeah, we have time for 3 questions.
3 questions. Cool. Very quick hand back.
So, correct me if I'm wrong, but it seems in sharing the code often you seem to be advocating pushing to master.
Yes, often, yes.
Then where in your ideal build cycle would code reviews fit?
So we have different teams that do this in different ways. Quite a few teams do pull releases, do pull requests, and just do very frequent pull requests. So you get lots of very small reviews, which actually works quite well. It makes people much better at reviewing. It's much easier to handle these kind of things. Other tools will let you do reviewing on master, on trunk, in quite a lot of places. So Crucible, that's in a lot of ways what it's quite keen on. You can go through and say, I'd like to open a review for this selection of commits, and then look at that. It requires enough rigor to make sure you actually do that, but teams get better and worse at that in places. You can build in the review wherever you like, and you don't necessarily have to be immediately committing to master. The goal is to get stuff to master as quickly as possible. And similarly, that involves getting quick reviews on stuff, if you're going to put that in as the blocker. Another question? Yeah?
If you have so many small reviews and commits to master, doesn't that require the developers to make context switch all the time from their code to review and back?
Interesting. So do many small commits require a lot of context switching? So we don't really notice that. Mostly we have technical leads on the project doing reviewing, and they end up doing a reasonable amount of context switching, but context switching between a sequential series of reviews. And we also spread that around the team, so we certainly open up reviews to everybody, typically. But people typically, I guess, tech leads will immediately pick stuff up, and then the rest of the team, in between stories, will look at the reviews that have come up recently, have a quick look through, make sure they know what the team is doing as a whole. So you've got a kind of quicker loop there and a slower one that doesn't get in people's way. It's certainly not something we've really seen that much as a problem. It's worked quite well. And the third and final question. Cool, perfect. All right, I'll be around, so do come and ask me any questions later on for the next while, and then the party. Yes, thank you.
Time for a coffee break, yeah?